Hello everyone. We are going to do lesson 7 today. It begins on page 29 in your book. So this is the objective of the lesson. You're going to be solving word problems involving the volume of rectangular prisms with whole number edge lengths. So basically word problems involving finding the volume of prisms like we have been doing, and the measurements of the edges are going to be whole numbers, which is something we've also been doing already. All right, we're going to look at, again, I'm on page 29. I'm looking at the first problem. It says Jeffrey builds rectangular planters. If you need to pause me right now, you can do that. All right, it says Jeffrey's first planter is 8 feet long and 2 feet wide. The container is filled with soil to a height of 3 feet in the planter. What is the volume of the soil in the planter? Explain your work using a diagram. All right, right now I want you to pause me and draw what you think this looks like. Okay, here's what I have drawn. I've labeled 2 things so far. So from what they've given us, I know that his container is really long because it's 8 feet long and it's only 2 feet wide. So I've drawn, it's okay if your picture doesn't completely match what I have, don't worry. I've drawn that the length is 8 feet and the width is 2 feet. Now they tell us that it's filled with soil to 3 feet, right? So I don't know the actual height of the planter. They didn't tell us that, but I do know that they've taken this container and filled it with soil up to 3 feet. That doesn't necessarily mean it's full. It doesn't necessarily mean it's not full. All I know is that there's 3 feet of soil in this container. So I can just draw, I'm going to draw what it would look like if there was some soil in it. Okay, so there's my beautiful drawing of the soil where it would be filled up to, and it has a height of 3 feet. Now, this problem wants us to give the volume of the soil, not the volume of the planter. So let's see if we can do that. We know volume equals length times width times height. So we have the length of 8 feet. We have the width of 2 feet. And we have the height of the soil, not the height of the container, the height of the soil, which is 3 feet. Okay, now pause me and solve this. Okay, for that one you should have gotten 48 feet cubed. We're going to move on to the second problem, which is still about Jeffrey. It says that he wants to grow some tomatoes in 4 large planters. So we're making 4 large planters. He wants each planter to have a volume of 320 cubic feet, but he wants them all to be different. Showed 4 different ways Jeffrey can make these planters and draw diagrams with the planters' measurements on them. Okay, so some things I know. We need to make 4 different planters. Each of them has to have different dimensions. I also know that the volume of all of the planters is going to be 320 feet. Is it feet? Yeah, feet cubed. All right, let's talk about what we know about volume. We know that length times width times height equals volume, right? In this part of the equation, we already know what the volume is. The volume is 320. So basically what we're in charge of doing, or what we need to do, is find 3 different numbers you can multiply together to get to 320. So the way I would think about this is the number 320 has the number 32 in it. They've given us a multiple of 10, which is nice because 320 is an easy number to kind of work with. So I want you to think of 3 different numbers that can multiply together to get to 32. So try to find one of those now. Think of 3 different numbers to get you to 32, not 320, 32. All right, I will explain my thinking for this doesn't equal 320. I thought of the numbers 4 times 4 times 2. So I know that 4 times 4 is 16, and then I was thinking, all right, I can multiply that by 2. These numbers equal 32. 4 times 4, 16, times 2 is 32. These numbers do not equal 320. I need to get them to equal 320. So I'm going to look at these 1-digit numbers. I need to get this into 100. I know that if I just add a 0 to one of those digits, it's going to add a 0 onto my product here. So let's say I'm going to change that 4 into a 40. I could change that into a 40. I could change that into a 20. It doesn't really matter where you put the 0. So I'm going to attach it to the 20. So 320, 4 times 4 times 20. So we could assign lengths and widths to this. Let's say this is the length, width, and height. That is kind of a crazy planter, but these 3 numbers together equal 320. So now they ask you to draw what this planter would look like. So I have a length of, I think we're using feet, a length of 4 feet. I'm going to make it pretty small because it's going to be. I have a width of 4 feet, but what's really big is my height. So I'm going to draw my thing very high. I would never recommend making a planter like this. I don't know how you're going to draw tomato, or you're going to grow tomatoes in something that looks like this. Okay. Again, you guys know how bad I am at drawing, but I could label this is 4 feet. My width is 2 feet. My height is 20 feet. So in that box that they give you, you need to include a drawing like this, and then I guess an equation. 4 feet times 4 feet times 20 feet equals 320 feet cubed. So there's the first example for you. I want you to try to come up with 3 more. If you cannot, I'm going to show them on here. But first try, see what you can do, and then resume the video. All right, for those of you who might feel a little stuck, that's okay. I'm going to set up this next one. I'm going to start with the number 32. There's my first dimension. Now I need to think, if I'm starting with 32, what would I need to multiply 32 by to get to 320? Well, I would need to multiply it by 10, right? But I can't fit 10 here because I need 2 separate numbers. So then I'm going to think, all right, how could I make 10 by multiplying? 2 numbers that multiply together to get to 10 are 5 and 2. So you could do 32 times 5 times 2, and that gets you to 320. If you were to draw a diagram for this, you have a very long length and a pretty short width and height. And remember, these diagrams need to reflect actually what it would look like. Not perfectly, but if you have a really long length, you have to show that. So I'm going to erase this and redraw. Okay, so here's the diagram. Again, I'm realizing it's a little blurry. Hopefully it shows up better when you guys are watching it. My planter here is very long because my length is 32. I have a width of 5 and a height of 2. Okay, so for this next one, I'm going to start with the number 16 because I know that 16 can go into 32. So if I'm thinking of 16, 16 times 2 equals 32, right? But I'm getting to 320. So I'm thinking right now, 16 times what would get me to 320? Well, 16 times 20 equals 320. So again, I have two spaces to fill here, and I can't put 20 in both of them. So what I'm going to do is put 20 here, and then 1 here. It makes for kind of crazy dimensions, but 16 multiplied by 20 times 1 is equal to 320. All right, I'm going to pause and draw what this box looks like. It just took me a really long time to figure out how to draw this. You guys know I'm not an artist. So here we have a length of 16 feet, a width of 20 feet, and a height of 1 foot. So it's a very flat, long box. All right, we'll move to the next one more. All right, here's my last example. I chose to multiply 8 times 8 times 5. 8 times 8 is 64. 64 multiplied by 5 is 320. So here I've drawn it. This is probably the most normal looking box we've had so far, with a length of 8, a width of 8, and a height of 5. I will create a new video for the next page.